Let's go back to the ancient times of 2022. Stable Diffusion 1.5 was open released to the public, and it was a huge deal in image generation. It could generate portraits, mimic styles, and make funny images. But back then, we could only dream of having 5 fingers on a hand instead of 7. Turbo-lax and bright colors were just impossible fantasies. People would make fun of hands behind back images. That is until we discovered things like better fine-tuning and prompt engineering. So in 2025, we have dozens and dozens of alternatives for everything. I'm sure most people dipping their toes are super confused by the inconsistent information everywhere. Anything in this area goes stale in just a couple of months. Hopefully this video can guide you in April 2025, until of course it is depreciated as well. I'm going to start with defining some commonly used terms. I probably will miss a lot, because otherwise the video will be hours long. Let's start with explaining what fine-tuning is, because it's a very important part of machine learning models that you want to use. In simple words, fine-tuning is the process of further training a model with the images and captions you have created. Fine-tuning is a general term that encapsulates other terms such as LoRA and embeddings. In reality, for consumers like you and me, full fine-tuning our own model is not really viable, mostly due to VRAM requirements. It also involves collecting thousands or even millions of images, then cropping and capturing those. Fortunately, there are some hacks and techniques to make fine-tuning possible on your computer, which I will talk about in this video. Like I mentioned in the intro, image generation has come a long way, especially considering the whole thing is mostly self-funded by random people. In some cases, the cost of these independent projects exceed 5 figures, and almost all of the relevant models are freely available for personal use. In Civit AI and Hugging Face, you can find a shit ton of fine-tuned and merged models. I recommend checking active models from 2024 and 25 because new training techniques have been discovered, especially in the past year, increasing the new model quality substantially. For example, I jokingly mentioned some stuff about turbo-lax and such. The models weren't able to produce vivid colors due to some fundamental issues in the training logic. A lot of these issues were fixed, and there are some new ideas floating around as of 2025. Chances are, we still have some juice left in these quote-unquote old models. Keep in mind that SD 1.5 was released in October 2022 and SDXL was released in July 2023. It hasn't even been that long, but calculate everything in dog years when the topic is AI. Okay, let's move on to the currently used models and why they are preferred. As mentioned, SDXL was released around 2 years ago. It consists of 2 clip text encoders, a single VAE and a unit model, so text in, image out. When you download a fine-tuned model, the checkpoint file usually includes VAE and text encoders as well. Without a VAE, your images will look dull and wrong like this. Now that we have downloaded our first model, on GitHub, visit the Punchovix Reforge page and do a clean install like this. First and foremost, you need Python 3.11 installed. You probably will need to install Git and pip as well if you haven't done so already. Check out these links or ask ChatGPT for instructions. Then, run the WebUI user bat to start. If you have any issues at this point, I strongly suggest you to check the issues page or use Gemini to troubleshoot. Most errors happen due to a missing package anyways. After the install is finished, this very useful page opens. You will mainly deal with a couple of parameters first, namely prompt, negative prompt, sampling method, scheduler, steps, page count, CFG, seed and resolution. I know it's a lot and I could explain these for hours, but bear with me please. I will tell you the most basic stuff and let you figure out the rest. Okay, prompt is of course your prompt. Pretty self-explaining, right? You need to read a prompting guide for SDXL fine-tunes to exploit the potential in prompting. Most fine-tuned models use a pretty standard prompting technique called Denbower tags. You just list the details of an image like it was tagged in a Denbower page. Usually you start with the quality tags like masterpiece, high-res, best quality, etc. and define other things. You don't necessarily need to follow an order, but some models have very specific tags like score_9 and AWA. Thankfully you can copy these from a Civit AI page and play with it yourself. Next, negative prompt. Very clear definition, these are the stuff you don't wanna see. Again, usually you list tags, which are things like low res, bad quality, blurry, etc. Some people use very specific tags like fused fingers, multiple digits, and such, but I really doubt these work in a meaningful capacity. Then we have this very cryptic sampling method and scheduler type stuff. You will use Euler, ULA, RSTE, or DPM++ 90% of the time. These let you denoise and create an image out of nothing. Euler and Euler A usually produce flat results which are good for illustration type generations. RSTE is relatively new and produces good quality images. DPM++ 2M is also quite good, especially for realistic images. Schedule type defines the sequence of noise levels that the sampler will target at each step. Don't worry about what that means, start with automatic and try the others yourself with a fixed seed to compare the results. I personally like KL Optimal, Phi and align your steps. The step count. This lets you denoise the latent noise step by step until the desired image is produced. More steps does not necessarily mean a better image, so you should keep this between 20 and 40. I prefer 20, 24 or 30 because more steps means slower generation as well. Width and height are also self-explanatory, but you need to see this resolution table for SDXL. What's the point of this, you might ask? Well, if you choose to generate in a very strange resolution, the generated image will most likely end up looking disfigured because the original training images were specifically in this resolution. Classifier-free guidance is kind of like a middle manager for you. Too low CFG will cause the model to drift and generate blurry, noisy, and more randomized images. Too high CFG will cause generated images to be fried and disfigured, just like a micromanager on your ass. Roughly between 4 and 8 is a good range. Lastly, let's talk about the seed. Seed exists in almost all machine learning models. It's a pseudo-randomization that lets you both reproduce results and generate infinite different outputs. If I give my seed, resolution, CFG, and prompts, you will be able to reproduce my generated image. There is a lot of nuance and exceptions to this, but again, this is already taken too long, so I won't branch out here. If you are interested in anime and illustration type stuff, almost everything you have seen that's AI generated or AI assisted comes from a random STXL fine-tune, including NSFW stuff. Especially those. STXL has a huge community and a good amount of private money behind. There are a lot of tools like ControlNet, which lets you use reference images, poses, and more. In this video, I thought about going over Flux more, but I realized I am too lazy and I hate long videos, so I shall pass on the Flux for now, but it's almost the same in terms of use. However, I highly recommend ForgeUI from Ilyas build instead of VForge. It offers more control and you can use GGF models to heavily reduce the VRAM requirements. Maybe I will make a separate video of our Flux later, because while it's very similar to STXL, there are a couple of differences, and this might cause unnecessary confusion. To reinforce the information we have received so far, I'm going to create my own images and think out loud while doing so. Let's run the Gradient UI first. Okay, I'm using the Hasoku model checkpoint and it already has VAE and clip included. I don't have to worry about any more files. The UI offers a lot of extensions by default, but I'm not interested in these for now. I will define the quality tags first and write a simple prompt. Next, I will add some well-known negative prompts that affects the generation quality. Almost any resolution is okay with this model, but well-defined ones should again improve the quality. Let's go with a horizontal resolution. You can't go wrong with ULRA and KL Optimal. This is a very stable combination of scheduler and sampler. My GPU is strong enough to generate in batches of 8, but I will generate one by one to see the minimum VRAM use. This model requires a low amount of CFG, so 5.5 should be fine. Seed will be random as I'm not reproducing any results for now. Alright, this looks fine. The edges are a bit wonky and 1 megapixel is quite small, so not much detail will fit in anyways. If I had OBS and DaVinci off, it would use around 10 GB of VRAM. Many GPUs have at least 12 these days, but also fuck you Nvidia for still releasing 8 GB cards in 2025. Anyways, back to the image, we definitely can improve this without any effort. High-res fix basically creates the image in a higher resolution by using an upscaler in the process. Yes, you could use just an upscaler instead, but here's the twist. High-res fix adds more detail to the image by using the model, but this comes at the cost of time and VRAM. A lower denoising strength is more stable in my opinion, and 0.6 is usually fine. Since we don't have all the optimizations applied, the peak was huge as expected. If you don't have this much VRAM, your CPU RAM can also handle this final peak as well, but it of course will take much longer. You clearly can see the difference between images here. The high-res fix with 4x anime upscaler sharpened the image and improved the details while keeping the image practically the same. You can see how much natural high-res fix looks here. Now let's take another step to fully optimize the process. Go to settings and optimizations under stable diffusion. I know, there are a lot of big words here, but don't worry, you won't deal with most of these. One thing you can try is to skip applying negative prompts in some steps, which will improve the speed at the cost of some quality. You can also try other attention types here to see if there is one works well with your GPU. Padding has no effect in quality, but it does improve speed due to some technical stuff. Lastly, FP8 weights can be activated as well. This also will cause a minuscule drop in quality, but you will use significantly less VRAM. After applying the changes, you'll get the scary screen, but it's just a visual bug. Restart the client for good measure. With these optimizations enabled, you can easily run the STXL on a medium budget card like RTX 3060, that's for sure. When I batch 4 images, I do get a brief spike on memory use, but like I mentioned, it's fine since your GPU will automatically offload the CPU RAM when needed. Also keep in mind that I'm fast forwarding these because I don't want to waste your time. So this generation doesn't actually take like a couple of seconds, it takes around 9 seconds per image, and this is with my RTX 3090. With that in mind, can we actually go even lower? The answer is, of course yes we can. The easiest way is to scroll down here and enable Never OOM. You can try tiling the VAE, which will decrease the VRAM use without practically any downsides. If you haven't noticed, the memory spike that usually occurs at the last step did not happen this time. Because during the last step, variational autoencoder takes over the process to produce the final result. When you tile it, it doesn't use as much memory. But we can go lower. Even your potato laptop will be able to handle this. By enabling this for UNet, you are offloading stuff to your CPU like we do in LLMs. But this is more efficient for some reason. Don't ask me about the technical details, it just works. In 2025, you don't need an expensive GPU or a crazy system. This obviously is a lot slower, but just the fact that you can run this on anything is impressive by itself. To have the best experience, you should have an NVIDIA GPU. STXL works with AMD cards and even purely on CPU as well, however the install process is a bit more complicated. For example, you'll have to install ROCm, set up Zuluda, and configure some environment variables. I would suggest asking to Mr. ChatGPT or following a guide that was created after 2024. Let me give one last tip to AMD users. Go visit the Stable Diffusion WebUI Forge page, then click the forks. Here you'll see the forks of this project, which are supported by different people. For example, there are 2 AMD versions of this WebUI. These should support AMD GPUs out of the box without any major issues. This one has over 100 stars, so this should be pretty reliable. When I scroll down here, there should be an installation guide, of course. Here in Zuluda, most of AMD GPUs are compatible. Start WebUI with use Zuluda. The installation process is pretty much the same, you just use this link instead of the one I gave you at the beginning. So you just git clone this one and install as usual. Last things last, let's talk about LoRA, the salt and pepper of AI models. Let's say you have an original character that you draw yourself, something that doesn't exist on the internet. Obviously, this character will not appear in the model when you write its name because the training dataset did not include any examples of it. All you need is a couple of example images and a gaming GPU to teach this new concept to a model. Basically, you sample a very small amount of parameters and fine-tune those instead of the whole model. Well, you don't even have to train it yourself. Whatever you are looking for probably already exists in Hugging Face or Civit AI. Now, LoRa's are mostly compatible across models that share the same architecture. So if you've got 2 models that are based on Stable Diffusion 1.5, you can usually use the same LoRa with both unless the fine-tuned model was trained with new techniques or something wildly different. If the LoRa model was trained on Stable Diffusion 1.5 and your base model is STXL, then that LoRa won't work. Different architecture means different wiring under the hood. Another thing is that you can actually combine multiple LoRa's. So, if one LoRa is trained on a certain character and another is trained on a specific art style, you can mix them together. It's a really cool way to get custom results like you see here. You just need to download the small safe tensors model, which is usually less than 500 MB in size, and put it inside models/LoRa folder. Make sure that you are always using safe tensor files. Most LoRa's use a trigger word, which is usually mentioned in the model page or exists inside the file like this. You need to use this trigger word or phrase to get the best results. For example, this is the raw result without the LoRa. I'm also using the same seed to reproduce the results. And this one is with the LoRa. You can also reduce or increase the influence of LoRa like this. Okay, I think this has been a decent introduction. These are the important stuff I haven't talked about, because otherwise this video would be an hour long at least. I might go over them one by one later instead of lumping all of them together in a dense long video. To be honest though, the best way to learn is by exploring stuff yourself. Visit Civit AI, Hugging Face and TensorArt for more resources. Please be responsible, rational and civil. Don't forget the fact that this field is still developing and the regulations are very vague. Please don't use these tools to create or distribute legally and ethically unacceptable material. Anyways, I hope you enjoyed the video and learned something new. Bye!